Hello, welcome to the AIOH e-learning program from the Department of Science and Education. My name is Dino Maturano. I'm the Scientific Education and Training Manager here at AIOH, and I'll be your monitor today. Today's webinar, surface limits. How are they derived? How should they be used in industrial hygiene practices? With that, I'm going to hand it over to Hugh Davies. Hugh, you're up.
Thanks very much, Dino. Good day, everyone from the West Coast. My name's Hugh Davies. I'm an associate professor in occupational and environmental health at the University of British Columbia here in Vancouver, Canada. I'm a CIH, a member of the TLV Chemical Substances Committee. I teach hygiene here at UBC, and my research includes using surface wipe methods in characterizing anti-neoplastic drug exposures, both in hospitals and other settings. I'm joined today by three accomplished and outstanding presenters whom I'd like to introduce to you now. They all have impressive experience in this field and given considerable thought to today's topic, and all of them have published on the subject. First up will be Tracy in just a minute. Dr. Tracy Kimmel is a principal toxicologist for SafeBridge Consulting. She has 25 years of experience in the pharmaceutical industry, culminating as the manager of hazard assessment and characterization at Pfizer. She's a diplomat of the American Board of Toxicology, and she's also a member of the TLV Committee for Chemical Substances and previously a member of the WHEEL Committee. Following Tracy will be Bruce. Bruce is a consulting toxicologist, 30 years of experience as an industrial toxicologist, and formerly the executive director of toxicology at Merck's Global Safety and Environment Group. He also chaired the Merck Industrial Toxicology Advisory Committee, which sets health-based exposure standards. Bruce is certified by the American Board of Toxicology, and he's the vice chair of the ACGIH TLV Committee for Chemical Substances. Following Bruce will be Susan Arnold. Dr. Arnold is a CIH, an assistant professor of industrial hygiene at the University of Minnesota, and the director of the Exposure Science and Sustainability Institute. She has 20 years of experience in exposure assessment and modeling, is an AIH fellow, and was the 2016 chair of the ACGIH Board of Directors. Why surface limits? Well, of course, the dermal route is an important contributor to occupational exposure. Prevalence of occupational disease is great. It's vastly underestimated, and it's probably increasing. And dermal diseases like allergic contact dermatitis are very common and can be significantly disabling. And of course, it is a problem for many different fields, as these illustrations show. The TLVs have previously recognized this and still do with qualitative notations like skin and the sensitization notations. But quantitative limits have much greater utility. To paraphrase Peter Drucker, if you can't measure it, you can't understand it. And if you can't understand it, you can't control it, which sounds like it could have been written by a hygienist, not a management specialist. Quantitative measures give us more. They give us targets for maintaining a healthy workplace. They allow us to evaluate interventions, identify best practices, and they have great educational power. But setting surface wipe limits has challenges. While the underlying concepts are the same as setting airborne limits, there are significant differences in dermal versus respiratory uptake mechanisms and physiology that have to be taken into account. There are major limitations in the amount of appropriate experimental and observational data that are available to do surface wipe limit setting. Nevertheless, surface limits are being used in some industrial settings, and more requirements to use them are coming, like the USP 800 in pharmaceutical practice. And recently, the ACGIH TLV Committee adopted the new threshold limit value surface limits, and two substances, orthophthalaldehyde and methyl tetrahydrophthalic anhydride isomers, became the first two substances to be given these surface limits. So this webinar is an introductory look at surface limits, how they are set, how surfaces may be measured, and how surface limit exposure data can be interpreted, and to help industrial hygienists incorporate them into their practice. Our first two speakers, Tracy and Bruce, will cover the theory of surface limit setting and go through a case study of surface limit setting using a specific approach. And then we'll break for questions on those two presentations. Then Susan Arnold will pick up and present an overview of surface sampling methods. And then finally, I'll be back to talk about what you might call the industrial hygienist perspective. And Susan will have some closing comments. So here are the learning objectives for today's presentation. Understand the basis for surface limits, understand how surface limits complement other TLVs, describe which chemicals may need surface limits and how they're derived, understand standard wipe sampling methods and other analytical techniques, describe the interpretation of wipe samples, and then understand how to incorporate surface limits within an exposure control program. And with that, I'll hand the microphone over to the first presenter, Tracy.
Thank you, Hugh, and good afternoon, everybody. I'm just going to really quickly walk you through some of the basics of setting surface limits. To expand a bit on what Hugh mentioned, TLV SL surface limits were recently approved by the ACGIH TLV committee and are meant to serve as a supplement to airborne TLVs, particularly ones where we know that there's a potential for significant toxicity resulting from dermal absorption. Those would be chemicals that carry notations, either skin notation or sensitizer in the form of DSEN or RN notation. The TLV SL represents a safe level of exposure via direct or indirect contact to chemicals that are deposited on workplace surfaces. And as you already mentioned, there were 2 approved TLV SLs as of 2018. And I'm glad he said them because I don't have to try to pronounce them again. Why do we want to set surface limits? In a nutshell, it's because, as you all know, a lot of workplace activities can be high energy and they generate dust or aerosol clouds. There's a lot of potential for workers to inhale aerosols or dusts from those clouds, but some of the chemical can also deposit on the surfaces of workplace equipment, sometimes below levels of visibility. I mentioned that the threshold for visibility of dustiness is on the range of 100 to 500 micrograms per 100 square centimeters. If you see something above that surface concentration, you will know that it's dusty, but things can be present below that level, meaning they're not visible to the eye, but nevertheless capable of producing systemic effects if dermal contact occurs. Sometimes contact does occur between a worker and what I'll call contaminated equipment, resulting in chemical transfer from the surface to the worker. And if that transfer takes place to exposed skin, the chemical can be systemically absorbed through the skin and from there migrate into the bloodstream to produce the toxic effects. This is a rather crude illustration, but just to show you, here is your dust or aerosol cloud. When it's not the part, I'm sorry, some of it can be inhaled by the worker, but some can also deposit on the equipment surface, which is here. If the worker makes contact with the equipment, the chemical can transfer either to the hands, gloves, clothing, or shoes. And if any of these are exposed areas, directly to the skin. Additionally, if the worker does not know that he or she has chemical on himself or on the protective equipment, an inadvertent transfer of chemical can be made to the face and neck area just by scratching an itch or adjusting a glove. So that is the scenario. There are different ways to set surface limits. I'm going to talk about setting limits for systemic effects, following which Bruce will talk about setting limits for sensitizers. But in all cases, the setting of surface limits starts with identifying a safe dose. For For systemic effects, the safe dose is pretty much the same as the one that you would be used traditionally to develop either a TLV, TWA, or a TLV STEL. You go through your hazard assessment, you review all the data, identify the critical endpoint of concern and the dose associated with that endpoint, apply your adjustment factors and calculate the safe level exposure, at which point you divide by the breathing volume to get a value in milligrams or micrograms per cubic meter or other mass value per cubic meter. And at this point, I just wanted to apologize. There's a correction that needs to be made in this slide. Please delete the reference to STEL in the next line item. So when you're setting a surface limit, one thing that you can do is you take your TLV TWA and you multiply by the breathing volume, which is 10 cubic meters, to get what I'm going to call an occupational ADE, where ADE stands for acceptable daily exposure, also known as a permitted daily exposure, or PDE. But I'll just talk about an ADE. So starting from the TLV TWA, you take your safe level. That would be, you take your occupational ADE, the TWA, times 10 cubic meters, divided by the standard surface area, which is 100 square centimeters, corresponding roughly to the surface area of one human palm, and make adjustments as needed for dermal bioavailability. The equation looks like this. Here you have your occupational ADE divided by 100 square centimeters and the adjustment made for dermal bioavailability. And I'll run through a really quick calculation for you. You have the TWA TLV of 0.5 micrograms per cubic meter. Convert that to an occupational ADE by multiplying by 10 cubic meters to get 5 micrograms. Adjust by 10% for dermal bioavailability. Your net result is 5 micrograms divided by 100 square centimeters and 10%, or 0.1, to give you a TLV SL of 50 micrograms per 100 square centimeters. Just a quick note, surface limit values can be anywhere, but anything above 100 to 500 micrograms per 100 square centimeter is not going to be all that useful, because those are in the area of limits where you can see the actual dustiness. The ones that we want to focus on are the surface limits that control against exposures below the levels of visibility, and referring back to that threshold which I mentioned before. Now, Hugh commented in his opening talk about how difficult it is to get information about dermal absorption. It's true, it's very hard to come by, and a lot of times you have to rely on some secondary approaches to make predictions on absorption potential. Some guidance that was put forward by OECD suggests that it's possible to predict the dermal absorption potential by looking at 2 physicochemical properties, specifically molecular weight and the octanol water partition coefficient, or log KOW. According to OECD, if a chemical has a molecular weight below 500 Daltons and a log KOW between -1 and +4, you can assume that there is a high absorption potential and set your absorption at or near 100%. On the other hand, if one or both of these criteria are not met, you can assume a low absorption potential and set your bioavailability or absorption at or near 10%. So that's one way to predict absorption potential. Another way is to look at results of animal studies where the route of application is dermal. So if you're applying a substance to the animal's skin and you're seeing systemic effects, it's clear that the absorption is taking place in amounts sufficient to cause some systemic toxicity. You can therefore assume that the absorption is high, or at least high enough to cause the effect, and to be conservative, assume it's about 100%. So that's how to set a surface limit from a TLV or any other occupational exposure limit. But what happens if you don't have a TLV and you still want to set your surface limit? There are a couple of approaches that you can take, starting with mapping surface limit values against exposure bands. By this I mean if you're working with an exposure banding system and you have a chemical that's assigned to one of your exposure bands, you can set surface limit values for the less hazardous bands and reduce them for the more highly hazardous bands. The low hazard band may correspond to a surface limit value in the range of 100 to 500 micrograms per square centimeter. That's at the threshold of visibility. And you may, for example, want to drop by a power of 10 as you go through each progressively more hazardous band. That's an approach that you can take, but it's not perfect. It's not data-driven, which means it has more arbitrariness to it, and it may not be appropriately conservative. Nevertheless, it's something that you can do as an alternative to nothing. Another way that you can set a surface limit without TLV is if you happen to have an ADE or a PDE, convert that value to an occupational ADE and run through the equation that I just showed you. Some differences have to be taken into consideration though, starting with differences in bioavailability by the various routes of exposure. If, for instance, the ADE is set from oral data, you have to make an adjustment from oral route of absorption, the oral route absorption to dermal route absorption. Also, what must be taken into account is that there's a difference in the level of risk between a patient and a worker. It's generally assumed that workers are willing to accept a higher level of risk than a patient, and that can factor into the calculations. Lastly, there are differences in demographics between patients and workers, where workers tend to be viewed as more healthy than the patient population. My final note applies to setting surface limits both with and without TLVs, and that is to use caution because the critical effect that you're using to set your surface limit might be different than the one that you're using to set an inhalational exposure limit. That may be just because the dermal exposure may give rise to a more concerning systemic effect than what might occur from inhalation exposure. The surface limit process is a work in progress, and there's a lot of ways to go before we can say with confidence that we fully understand it. It's not as straightforward as the inhalation exposure limit, where you can say 8 hours a day, 5 days a week, et cetera, et cetera. The biggest problem with understanding what you're doing when you're setting a surface limit is characterizing the exposure scenario for a dermal contact with equipment surfaces. By setting your standard surface area at 100 square centimeters, we're assuming that 1 hand touch per day takes place. That is the exposure scenario. But do we know that that is true? There can be more than 1 hand touch per day. There can be a slight brushing against the body, so it can be higher or lower than 100 square centimeters. The next problem is we assume that the transfer from the equipment surface to the skin is complete or 100%, but that may or may not be the case. Some chemical substances may be partially retained on the equipment surface, either due to their physical properties or to some things like static charge. There may also be ambient workplace conditions that influence the amount of transfer that's occurring, such as humidity. And the last thing that has to be kept in mind is that we are assuming when setting surface limits that the contacted skin is healthy. Healthy skin has a keratin layer which functions as the ultimate barrier to keep foreign substances from entering the skin and eventually the bloodstream. If the skin being contacted with the contaminated surface is damaged or diseased, the keratin layer is compromised, and there may be a higher potential for skin absorption. I don't have the answer to any of these questions. I just wanted to make you aware that we have a ways to go to answer them all, just some things to keep in the back of your minds when understanding the setting of the surface limit. So those are the basics I wanted to cover, and with that I will hand over to Bruce, who will talk to you now about his case study.
Thanks, Tracy. So that's a good overview, and I think you probably got the impression already that surface limits are kind of complex, setting them, and certainly later we'll talk about how you actually do the surface sampling and interpret the results. So part of learning about setting limits is to understand some of the limitations or some of the science around actually setting the limit. And so the two concepts that you just heard from Tracy are trying to identify a specific dose that you're trying to protect against through the dermal route. And in this case, in the case study that I'm going to talk about, it's about trying to find a level of external contamination that will not cause skin sensitization. So hopefully at the beginning of this talk, we're trying to communicate that there's a certain amount of science involved with setting surface limits, maybe even more than involved with setting airborne limits. Not that that's an easy task, but hopefully we'll give you a little better background. And I think the takeaway here is that while getting some background information and going through this particular example, the key is really understanding what is the basis for the surface limit for whatever compound it is. We have 700 or 800 TLVs. Many of those have skin notations, and certainly a lot of them have descend notations. So we've got a lot of work ahead of us, and we're going to have to figure out how to prioritize these. But the key will be in reading the documentation when we get around to doing that and really understanding the basis for the surface limit before you go and apply it. So in this particular, I'll try to highlight some of those points in this particular case study. So I'll give a little background on sensitizers to help get you in the right mindset. The use of the local lymph node assay to identify skin sensitizers for classification purposes, and the general use of that same study to set surface limits using the EC3 value, which is the effective concentration for a threefold increase in activity in that assay. And so I'll show you how we go through the calculation, and then I'll end with, okay, fine, we have a surface limit for a skin sensitizer, what do we do with it? And so the key is how to incorporate that new limit into your overall program. So you probably already know that sensitization is an immunologic mechanism that's behind it. An effect on the immune system that causes people to become sensitized. And that should be not confused with other terms that we use in risk assessment, like sensitivity or hypersensitive or susceptible individuals. And so it's different in that respect. And I think most of us know that, sensitization is kind of a unique endpoint, that you can perhaps be exposed for a long time to a sensitizer and not become sensitized, and then one day, all of a sudden you develop occupational asthma to laboratory animal allergy or something similar. So you can become sensitized, and it's not clear whether it's chronic exposure to low levels or if peaks are important. The point is how you get sensitized, and then once you're sensitized, you can react to a very low level of the compound and have a pretty severe reaction. In fact, asthma can be lethal, and so there are some pretty intense skin responses too that can result from skin sensitizers. And we're all familiar with what poison ivy feels like, or some of us. The ones that do know what I'm talking about. And these reactions, as I mentioned, like especially with the respiratory hypersensitivity, can be quite serious, life-threatening. And some of these, I'll go into this in a little bit more detail, but some of the reactions may be immediate in onset or delayed in onset. So there are some other common things about sensitizers, just as a way of background, that workers that become sensitized to one agent may actually also be allergic to other agents that are chemically similar. We know that despite some myths out there that say that there's actually no safe level for a sensitizer, that may be true for some individuals, but generally the reduction in exposure to sensitizers or similar compounds generally reduces the frequency or and the severity of the reactions. But as I mentioned, there are some people that are so exquisitely sensitive to a particular compound that really the only way to avoid allergic reactions in these individuals is to actually remove them from exposure and reassign them. And that can have a very significant impact on an employee's career. So obviously it's very important to get this right. So there are two different types of sensitization, and what's the difference between dermal and respiratory sensitization? There are differences that relate to the mechanism, the route, and even the symptoms that are exhibited. Dermal sensitization is considered a T-cell mediated or type 4 hypersensitivity response, allergic contact dermatitis. It's induced by dermal exposure and typically manifested as a skin rash. The respiratory sensitization, on the other hand, is B-cell mediated through allergic antibody, IgE, and is described as an immediate hypersensitivity reaction typically, along with anaphylaxis and a couple other serious ones. So bronchoconstriction, you get the itchy eyes, rhinitis, etc. And these respiratory sensitization can be induced by both dermal and inhalation exposure, which is kind of unique, and also shows that surface limits could be helpful for both dermal and respiratory sensitizers. So with the change from the old designation SEN, which included both dermal and respiratory sensitizers, we now have two different designations. We have a DSEN notation and an RSEN notation, and this dichotomy helps us focus our attention on what the actual hazard is. And there are some differences, as I'm describing, and importantly, what the appropriate controls might be. And the whole goal here is to prevent future cases of dermal and respiratory sensitization. Again, once you're sensitized, it's kind of hard to control exposures to prevent reactions. But if we can prevent the induction of sensitization in the first place, that's really where we ought to focus our efforts. And so Dr. Arnold and I published a paper a couple months ago on setting surface wipe limits for skin sensitizers in the Journal of Toxicology and Industrial Health. And so the example that I'm giving here is one that we included in this paper. Just want you to be aware of the fact that was published recently, and you could read that for more details. As I mentioned, the mechanism of contact hypersensitivity is somewhat, it's different, but there are some commonalities between that and respiratory. On the left-hand side, you see sensitization and induction, or induction. And these are the terms that basically describe becoming sensitized on the left side and then having reactions on the right-hand side. And induction and challenge are the terms we use in the toxicology studies that look at skin sensitization. So the chemical is absorbed, and that's kind of the key point. And Tracy discussed the importance of physicochemical properties, log KOW, etc. Essentially, the chemical has to get into the skin, and then once it's there, it has to be reactive enough to interact with proteins. So you create the hapten, or an antigen, in the skin, and you have certain cells, Langerhans cells and other, which are dendritic cells, and they're basically antigen processing cells, and they bind to and process the antigen and present it to T cells in the local lymph nodes. And so the local lymph node assay that we have in the mouse is predicated on this understanding of the mechanism. So the left-hand side is induction, and that's what we're trying to prevent, because once that happens, you get a clonal expansion of these lymphocytes. Now they're turning from orange to blue here. And then they're populating the skin, same area of the skin, other parts of the body. So you're actually, when you become exposed to the same chemical or a similar one later, you have the chemical interacting with these T cells that now recognize that particular chemical. They're chemical specific in that sense. And once they bind to the chemical, it triggers a whole series of reactions that ultimately leads to the wheal and flare, the redness and swelling, et cetera, that's associated with allergic skin rash. A slight variation on this would be, the B cells, rather than T cells, you have the B cells and they're creating antibodies, but ultimately some of the same mediators of inflammation are involved that result in bronchoconstriction and edema, et cetera. So there's overlap between the mechanisms, and some chemicals have the propensity to do one or the other. Some actually can do both. So during the validation of the murine local lymph node assay, there were a number of interlaboratory validation studies that were done. And this one shows the study that was done with dinitrochlorobenzene. And you can see that the stimulation index on the left-hand side, that is the amount of proliferation of that's going on in that lymph node that drains the ears where the compound is applied. These lymph nodes are in the neck area, and so you can see at 5, 10, 20 times, 20 times the level of proliferation above controls that can go on, especially when exposed to a compound like dinitrochlorobenzene, which actually happened to be the positive control in the guinea pig maximization test that the LLNA replaced. But the key thing here is to notice that there's a very clear dose response, where there's very little response at low concentrations all the way up to a very significant response, and how consistent it was between at least these two laboratories. And the EC3, you see with the blue line along the bottom, is the effective concentration that corresponds with a 3-fold increase in lymphocyte proliferation. So you need to have a response above the EC3 in order to classify the compound as a sensitizer under the globally harmonized system or REACH, et cetera. So this is something that causes most toxicologists to salivate over when they see a clear dose response curve with a very easily identified no effect level, or low L, no L, essentially a threshold for that response. And that is the key basis for setting surface limits for skin sensitizers. Oops. So here's a chart or a table that shows the correspondence between the local lymph node EC3 values in micrograms per square centimeter and the results of the human repeat insult patch test. So you can see that there's these are ordered from kind of strong to weak. Obviously, the lowest numbers that can cause these effects are the most potent. And so they range. You can see that the EC3 values here range at least 3 orders of magnitude. Similarly with the human repeat insult patch test results. And so some of these compounds that you recognize, and these were the compounds that were used in the validation studies. And this correlation between the human potency and the animal potency was used as the basis for proving the LLNA as a standalone replacement for the guinea pig maximization test. Now, this ratio here of the LLNA to HRIPT was kind of interesting to look at, because you can see that most of the values are above 1, right? There are 2 values that are less than 1. So that means that if you wanted to convert an LLNA EC3 value to a human no effect level, you're already beginning to think about a number at least on the order of 3 or so, maybe up to 6. And so those same data are plotted on this cumulative frequency distribution table, and you can see that the median is around 2 or 3, and the upper 95th percentile is less than 10. So even on the the far end here, on the kind of the edge of the distribution, we're talking about numbers of that are less than an order of magnitude. When you look into it more deeply, the Gerber paper was the one that we were just looking at, where we had a mean ratio of 2.5. And so Grime, some more recent studies looked at larger and larger numbers of these, and they tended to produce generally consistent results across the board. So you can see here, the mean ratio ranges from 1.6 to 4.3 roughly. And so, if you're going to use the EC3 as your point of departure for establishing a surface limit, and you need to extrapolate to a human no effect level, it kind of gives you an idea of the order of magnitude, roughly what you'd have to do before you started thinking about, any other adjustment factors. But there are good reasons why we should be thinking about other adjustment factors. So we have not only the differences between the two studies. Now, you can argue that using a ratio, you're covering both intraspecies and interspecies differences. But there are, a number of things that are different between the way these studies are done and the way workers may be exposed in the workplace. And so we describe them as vehicle or matrix related or exposure related. And so if you think about the contaminated surface, you have the pure substance there. And even if you contacted it with your hand, and people hopefully are wearing gloves anyway, but it's not, it's not the same. You wouldn't expect the same level of absorption to be happening there compared to how the study was done. When these compounds were mixed with petrolatum and put under occluded patches to facilitate absorption, et cetera. So that would kind of suggest that maybe, you don't need a lot of extra safety factors. But, the reality is there are sensitive areas of the skin around the face and the neck. There are situations where the compound can get down in your work boots or whatever. You have occlusive conditions under sleeves, et cetera. And it's not just a single test. I mean, workers can be exposed for their entire working lifetime, as I mentioned. And so chronic exposures have to be taken into consideration also. So in the end, we felt that there probably is a need for additional adjustment factors to be applied to the EC3 value. And so depending on the physical chemical properties, you're thinking about how this is going to be used in the workplace, under what conditions. Maybe the compound is going to be mixed with other solvents that are known to facilitate absorption, et cetera. But within your particular workplace, as you're thinking about setting surface limits, you need to take all of this into consideration. And there are a range of values, which I think I'll show on the next slide. But it looks like, an adjustment factor anywhere between 10 and 100 is probably reasonable. And, we were suggesting in the paper a default adjustment factor of 50. And that default composite adjustment factor of 50 reflects a factor of 6 for the variability around the EC3 HRIPD ratio, a factor of 3 for matrix considerations, a factor of 3 for exposure considerations. And these are like middle of the road values. So depending on your particular scenario, they could, you could think about adjusting them in either direction. One of the possibilities that came out during the review of the paper is, why not have the ability to have a sliding scale in terms of how strong the sensitizer is? So whereas the default would include a modifying factor, MF of 1, you could think about increasing that to 2 for a strong sensitizer and 3, for an extreme sensitizer, for example. So this shows how we could calculate a surface limit using the LLNA EC3 value. And this is what we did for orthothalaaldehyde. In this particular study, the murine LLNA involves placing 25 microliters of a solution onto each ear, which is estimated to be about 1 square centimeter. So the EC3 for this compound was quite low, 0.051%. And so when you calculate out what that means in terms of micrograms, you can see here that with 25 microliters, you're applying 13 micrograms to that, to a individual square centimeter. And so surface limit would be derived by taking that EC3 value and applying an adjustment factor. In other words, dividing by, pick a number, in this case 50, and then normalizing it to the surface area for the wipe limit of 100 square centimeters. So here 13 divided by 50 times 100 gives you 25 micrograms per 100 square centimeters, and that's the surface limit that the committee recommended for orthophthalaldehyde. So if you do that with the same series of compounds, you can see again that because of the difference in potency, and these numbers are different now because they're in percent and not micrograms per square centimeter, you can see what the surface limit results would be. And these assume a modifying factor of 1. If you applied additional modifying factors for the extreme and strong sensitizers, then the first 3 numbers would go down by a factor of 3, and the next 4 or so would go down by a factor of 2. You kind of get what I'm talking about. And so again, it's important to know how potent your sensitizer is, and nominally, roughly order of magnitude, what are we talking about in terms of a surface limit? Because as Tracy mentioned, once you get down around 200, 100 to 500, in that range there, it's not visible anymore. And, I remember having this conversation with Susan, and, at least in the pharmaceutical industry, we have a lot of stainless and everything's supposed to be clean. So the idea of only worrying about the ones that have surface limits that are below the level of visual detection is key. And she said, well, there are also some industries out there that aren't quite as clean. So, there is visible dust, and that in those cases, it may be more important to have a surface limit because you need to know how much of that dust could be represented by a skin sensitizer and causing a problem. So I think Tracy kind of alluded to the use of banding in terms of setting limits, so you can back into it that way, I guess. You can see here there's a 5 or 6 order of magnitude range of values that are that you can think of in terms of the various OEB levels in correlation with the occupational exposure limits. But from an application standpoint, each of these bands, and this is what we published a while ago, that there's a correlation obviously between the occupational exposure limit and the level of containment, the engineering controls that were required to meet those limits. And over time, we figured out basically what was needed to achieve 10 micrograms per cubic meter, or in this case, the corresponding wipe limit would be 100 micrograms per 100 square centimeters. So we have, at least in some industries, and hopefully it's, this could be useful here too, systems where we could set up ahead of time. If you have a surface limit within a given range, what the facility needs to look like in order to achieve those numbers. And so I put that in there just as a reminder that there are ways of backing into what we need to do to control skin sensitizers once we have surface limits. It's not done in a vacuum. Obviously, we're doing it because we think it could provide some useful information to the industrial hygienists as they're doing their jobs and evaluating exposures and recommending workplace exposure controls. Skin sensitizers are important. Hugh mentioned the prevalence of skin-related diseases and allergic contact dermatitis, et cetera. So, assigning a descent notation happens. You can make it part of your banding scheme. Obviously, there's a major hazard communication piece to all of this in terms of what shows up on labels and safety data sheets, how things are classified. And, we found that just the awareness of a compound having that potential really helps because workers will pay attention to how cleaning up after themselves, et cetera, a little bit more if they're aware of what that hazard is. Obviously, design of engineering controls and facilities is very key. And as I'm saying here, strong sensitizers probably do require some additional controls and special PPE considerations. For the weak ones, I think reinforcing good chemical handling practices, maybe some special considerations might be required, but that's got to be evaluated. Establishing good chemical handling practices is key. Using the right PPE, etc. Very important, especially for skin sensitizers. And then setting surface limits. So, we have the ability to do it. We should probably try to do that and do some monitoring and do what we can to verify the effectiveness of some of these controls that we feel are going to achieve that level of cleanliness in the workplace. So these are references that I mentioned in my talk, and the last one, Tracy had mentioned the OECD. They're in what was Dino sent to you. And so we have some time now to pause and answer any questions. Dino, did we have any questions come in while Tracy and I were talking that we can answer now, or shall we wait until later?
Yes, Bruce, we did receive questions.
Okay.
Tracy, if there were a couple that you were going to answer, could you please do that? And Bruce, could you please look at your question panel? Thank you.
Okay, so the first question that I saw came in was, what is a good source or reference for the alpha factor? That's in the list of references which Bruce just showed you, the OECD guidance document, which was published in 2011. I believe that's the most current edition of it. It's the reference that I used. So that's the first question that I saw. The next question is, Dino, can you read the second question? Oh, I see it. Why were these two chemicals chosen to be first to receive TLV-SL by ACGIH? And by the way, thank you everyone for submitting your questions. I'm going to let Bruce answer that one because he was involved more directly in development than I was, and because these were both compounds that were sensitizing, so I suspect there's a good connection there.
Well, they actually came up because of our chemical selection process, relying on information primarily from REACH registrations, and we have a way of prioritizing based on volume and also hazard, and we have an algorithm that we do that bubbles up compounds, and it just happens that these two were identified through that process, but happen to be pretty potent skin sensitizers, and we had been talking about setting surface limits for a while, so this was our opportunity to apply what we were thinking to those two particular compounds. But as I mentioned before, we have a lot of work ahead of us to prioritize not only the compounds that have been assigned sensitization notations, but also skin notations. There are other factors involved here too that are important in terms of the likelihood of absorption, as you mentioned, Tracy. But there's also some practical issues in terms of volatility. If you think about the inhalable fraction in vapor, ENDNOTE, or abbreviation that we use to identify compounds that have a high enough vapor pressure that would make monitoring them a little different. Whereas, you can't just collect the solids on a filter. You have to have a backup charcoal or whatever, the method you use, because you could be losing material as you're sampling it. Again, here, if it's highly volatile, it's not going to stay on surfaces very long to even be measured. Now, there may be workplaces where, there's some splashing or, there's potential for direct contact with liquids, and that, would be fair game. But again, it's how likely is it to stick around and then be picked up and by the skin and absorbed. So we've got to come up with our probably something similar to IFV to help prioritize these, also the effects that they're producing. So we've we'll do it that way. the one question that I had, it's kind of hard. It was more of a Tracy question because it was what was the basis of 100 to 500, and what is the relationship to particle size, if any? I don't think that that number is definitely not related to particle size, because it would be on the surface. You get agglomeration. You know, it would be piling up. You know, kind of like in a snowstorm. So I don't think particle size has a lot to do with it, except maybe the ability of the compound to even deposit. You know, you would expect larger particles to sediment and to accumulate on surfaces more than very small, you know, particle sizes that chances are would be removed by the ventilation system before they, you know, were able to settle onto surfaces. Maybe we can get Hugh or Susan to comment on that later. And then there was one other question regarding the 10% assumption, which I think was Tracy's area in terms of dermal bioavailability and the adjustment factor there. I think that's somewhat.
I didn't see that question.
Well, because
Sorry.
it was sent to me. So do you want to answer that, or should I take a crack at that one?
What is the question?
I'm trying to read it because it's in a small window. How would you recommend to handle the exposure to a sensitizer of a healthy individual? It's a dermal. That may be one question in its own right. Let's just pretend that that's a separate question. How would you recommend handling the exposure to a sensitizer of a I'm assuming it means a healthy individual. I don't think it matters whether it's healthy or unhealthy. It's, you know, the exposure controls are needed for both. And that, again, that's probably more of an industrial hygiene question that perhaps our other two colleagues can talk about. And then this other question is the dermal bioavailability adjustment factor 10% a constant? So I'm not sure what that means, but I think you answered it, and then you can elaborate further. But you picked 10 and 100 based on whether it's you know, maybe going to get in or be absorbed, or definitely going to be absorbed. But you also mentioned if you had data, animal data, that it could be anywhere in between, or even lower for that matter. Is that a reasonable way of putting it, Tracy?
Yeah, I'm just going to add to that, Bruce. The 10% and the 100% come directly out of the OECD guidance. Now, admittedly, the data set that was used to develop the OECD guidance was not necessarily the same data set that we would be using in general. I believe that the driving force was the agrochemical industry, not general industry or even pharmaceuticals. Those are just numbers that they went with. So all I can really say is that because they're published, they are out in the literature, and I would say that they're being looked at and perhaps maybe subject to change or more specialization for specific industries going forward. To the comment that you made about visible dust, Bruce, there are publications that discuss what I'm going to call the visible dust criterion, and pretty much nail it down in that range between 100 and 400 or 500. I'm not sure whether I put one of those as a reference that is included on the slide. If not, I can send it in separately to Dino after the webinar.
Okay, let's do that. And so let's continue on. It's almost 3 o'clock. We're about at the halfway point. We want to give Susan and Hugh plenty of time to present their material. So with that, we'll pass it over to
Bruce. Can I just sorry, one more.
Oh, go ahead.
There's a question that came in about developing limits for multiple contaminants, such as several heavy metals being handled in the workplace. I don't think that the science is far advanced enough to start thinking about surface limits for mixtures. Anyone feel free to correct me if I'm wrong. That's a really complex topic that will require a lot of thinking. And then we have a couple more questions that came in, which will be addressed by Susan and Hugh.
Right, and I have a few others that just came in, so we'll pick those up at the end after Susan and Hugh finish their talks. So with that, Susan's going to talk about methods of assessing surface contamination. I can't hear Susan. I don't know if she's on mute.
Hugh, are you ready to go? Maybe we'll come back to those slides.
Sure. Yeah, we give Susan a chance to get connected. Thanks very much. You can hear me okay? Yeah, so, okay, good. So I guess what I'll be doing today, just making sure I have control of the screen here. Just bear with me a second, please. Here we go. What I'll be doing today is basically going through some practical considerations for using surface limits in hygiene practice. As a number of speakers have already said, this is a work in progress, and I will certainly be talking from my perspective, and I'm sure that that other people have a lot of great and interesting perspectives as well, and perhaps we'll get to some of those or hear some comments during the question period. But I'll be talking about preparation and strategies for sampling, interpretation of the surface limit, the surface wipe exposure data that we collect, and incorporating those into exposure control plans or sort of into your hygiene practice. Like anything in life, being prepared is 90% of being effective and efficient. And again, it's already been said, and can't stress enough that hygienists access the TLV documentation for the substances which they are focusing on, and especially for surface limits because they are so new, and there is so much contextual information which is important in their interpretation. Of course, as ACGIH members, you get free documents. I think it's 10, and so no excuse not to have them and review them. There are other sources of documentation, the OSHA technical manual, chapter 2, peer-reviewed literature, which you've been sent some reference material, and I have a few references too. But really, I think this is an area that's new and evolving, and as hygienists, we need to really arm ourselves with as much information as we can. And certainly there's a lot of work still to be done in developing processes and procedures. Another thing which really helps, I think, is to clearly define what it is you're using surface limits for. If you have a clear research question or hypothesis, that really is the first step in interpreting this data. It's going to help you greatly. And knowing what your question is going to motivate also the selection of a sampling strategy, analytical strategy, and interpretation. So why do we measure surface exposures? Well, because there's lots of reasons. Compliance jumps to mind as for a lot of hygienists when we're forced to measure an exposure. But as Bruce has said, that the surface limits, surface exposure data has very strong educational power, and I've certainly seen that as well. You can use it to do simple preliminary risk assessment presence, absence of a substance, routine surveillance, such as the new USP 800 for pharmaceutical practice, intervention evaluations, has your cleanup worked, new processes, changes in tasks, and engineering controls and so forth, identifying determinants of exposure. So making sure you understand why it is you're starting, and making sure that your sampling strategy matches that is going to help greatly. Now, this is a very busy slide, to say the least. Don't worry, I'm not going to go through it in any detail, but I found this paper, which is in 2000 Annals by Schneider. This was a special edition of the Annals, which was looking at dermal exposures. I think this is very helpful in thinking about some of the issues that both the previous speakers have talked about, and just the what part of the very complex exposure environment or exposure scenario, as Tracy said, we're actually measuring. So this shows a sort of material balance model for the exposure environment, and we're interested in that top left corner, the surface contaminant layer. You can see the other compartments listed are things like air and clothing layers. And all those lines are the different transport processes. So if we focus on surface contaminant layer, you can see that you have deposition happening, you have decontamination, redistribution as things move around on the same surface, transfer to the skin contamination layer, removal from the skin contamination layer, and so on. And so I refer to this, and I had my students think about this a lot in answering the question, what is it we are actually measuring? And so, for example, when we think about what we're actually measuring on the surface contaminant layer, you're just measuring what exists at some snapshot in time. It's not an integrated measure like an airborne measurement sample. And bizarrely, or you're measuring basically what's left on the surface. So if you have a surface which has high level of contact by human hand or clothing, then a lot of what was on the surface has already been deposited on skin or clothing and is not there to be measured. So thinking about this, I think, is really helpful in understanding and interpreting the data. I think that just summarizes what I just said. So sampling strategies, this is the kind of who, what, why, where, when of sampling. And in terms of how many samples would one want to collect, often the question that's asked is how many samples do I need to collect, especially if they're expensive, as a lot of occupational hygiene sampling is. Well, sometimes it's going to be prescribed. So again, I'm thinking of the USP 800, which suggests how many surfaces should be sampled each year, and how many times a year. But if we have more flexibility, then we can certainly think about statistically based sampling. The basically statistical based just means that you plan to take a sample in an appropriate way that you can then assume that that sample is representative of the population that you are measuring, and allows you to do all sorts of inferential statistics. So that, I think, would be my go-to, or as a hygienist, if at all possible. But of course, you could simply be doing worst case if it was a simple presence absence kind of analysis that you were interested in. When to sample? Well, again, if you think that what you're measuring is a snapshot in time, it is an important consideration. So what time of the day or week? If you want to be just checking whether your intervention, your cleaning procedures are appropriate, then you would presumably measure right after cleaning. But if you want to know what an average exposure was for a worker, then you would probably be doing random sampling at representative times throughout the work day and and work week and so on. And knowing when to repeat, how often, again, may be prescribed or may be a result of some statistical plan or strategy. What surfaces to sample? What surfaces in terms of the locations within the workplace that you're going to sample? High contact is often recommended. So this is where the risk would be highest because of just the frequency or length of contact by human skin to the contaminated surface. But you can also think of other aspects that increase risk. So it could be toxicity, for instance, areas where the chemical is in a more concentrated state and so forth. Not necessarily, though, the highest, where you know there's the highest exposure. Sometimes it's actually recommended to sample where you might see the highest exposure, but that's not necessarily the highest risk. So for instance, in pharmacies, sampling inside the drug compounding cabinet is not necessarily informative because we know it's a highly contaminated area, because that's why we're doing the work inside the cabinet, and it's also cleaned regularly. Where to sample on a surface? Again, you need to think about this. If it's a large surface, you probably want to sample more than one 100 centimeter square area, but how many times, or how many areas, and how do you select which areas? Again, you can think about high contact, or you could think about random if you don't know what the high contact areas are. We are currently undertaking a study where we're looking at this kind of issue and trying to improve surveillance recommendations actually for the USP 800 guidelines. Some other sort of more practical considerations. A lot of wipe sampling is done by a kit that comes to you from a lab. And so, and you have, it's simple to do, so we don't necessarily always have industrial hygienists doing the work. Rather, we may have non-hygiene, non-OHS individuals doing the actual sampling. That in itself doesn't seem to be a huge problem. We've published work here which shows that you can get quite acceptable levels of consistency, inter-person consistency, low variability, with fairly modest training and standardized procedures. But it is important, I think, that you consider that, and depending on what your sampling strategy is, consider doing training to ensure as much consistency as possible. Things like transportation become an issue if you're using couriered kits. Making sure that the transportation timing minimizes shipping time and storage, and if you are going to store it, that it's stored at the appropriate temperature and so on. And then during the actual sampling, you want to avoid cross-contamination by using new gloves for each sample that you take, and new templates for each sample that's taken. In terms of once you get your data back, as I said, the interpretation given is going to depend very much on the question asked. So thinking about compliance sampling, I think that, as has been said, and we will repeat it, it's going to be critical that you start by trying to clearly understand what is the critical health effect. In some cases, you may be considering the TLVSL almost like a ceiling or a never to be exceeded, but it could be that there are surface limits that are more representative of time-weighted averages. So that is going to depend very much on the critical health effect. The language here is taken straight from the TOV documentation, and just, I think, illustrates that that is basically the guidance that is being given in the TOV documentation. The again, has come up already, a very important consideration is that the TLV surface limit is intended to supplement airborne TLV. So we did have a question that asked about combined exposures from airborne and dermal, and this is exactly it's a very good question and exactly the point that this is driving at here. You know, this is an acknowledgement, a quantitative characterization of a second route of exposure. So you must recognize that the cumulative dose in the body is going to be just that. It's going to be an integrated dose from both exposure routes. And so understanding both, or considering both in the response is going to be important. And certainly if you have significant dermal exposure, then you cannot assume that the inhalation or the airborne exposure or TLV is going to be appropriate any longer. But again, it will also depend on the health effect. And so reading the documentation for these and understanding it is going to be very critical. Can you use existing AIOH statistical methods? Can you use IH-stat and so on to interpret this? I haven't done this, but I don't see why not. Again, there's nothing special about this exposure data. They're simply exposure, they're observations that have been taken, and if you've sampled properly, then you can certainly use inferential methods to derive means and standard deviations and go on and do some you know, probability estimates. I think that's entirely appropriate and I would encourage it. But I think we also have to like continually go back to the how these are set, how surface limit standards are set, think about the health effects, and consider all these variables which are specific to surface wipe limits. So again, this is an area which is developing, as Tracy said, I don't think we have all the answers yet, but there's nothing inherently wrong with this approach. Outside of compliance sampling, we see a number of other interpretation strategies already. The USP 800, for instance, talks about detectable events or measurable levels and having to respond if anything is detected. So in other words, if anything is above the limit of detection. Now, the challenges, of course, with this is that it's not health-based and that the limit of detection varies by a number of factors, including the analytical instrument. So you're going to get different LODs between instruments, between analysis runs even, and depending on the surface area sampled. So this may be okay as a very crude kind of trigger, but I think we can definitely do better. And the next kind of approach that we see that is fairly commonly recommended are the so-called hygienic guidance values. Again, these are not health-based, but because they're based on previously gathered exposure data, they do have some benefits. So what's done here is that data is taken from the workplace being examined or from other workplaces that have so-called good occupational hygiene practice, and then we compare our exposure measurements to some percentile, usually the 90th or the 75th percentile of the previously measured site. So what we're doing here is at least comparing ourselves to other sites, and because of the use of the percentiles, we're, I guess, motivating or generating continuous improvement, because if you're continually striving to reach a lower percentile, you're going to be continually driving your exposure levels down. So those are the hygiene guidance values. For other research questions like testing interventions, then if you've done, you can look at simple pre-post comparison of means, determinants of exposure. We're doing work right now. There should be no problem with this data in terms of doing regression modeling, except one, and that is that depending on your work site, you may find that you have a lot of left censored data. So a lot of data below the limit of detection, which is going to take advanced statistical methods perhaps to analyze. So interpretation challenges, that's my first point. We do see a lot of data which is below the limit of detection, and that causes difficulties in interpretation depending on how you are approaching it. There's what we call a small surface area problem. So we traditionally measure the 100 centimeters squared, but if a lot of surfaces we want to sample are actually less than that, so a door handle, handle of a cabinet can be a high contact area but quite small, that in itself is not a problem unless you have a measurement below the limit of detection, and then when you divide through by the surface area, the sample limit of detection increases and can be complicated if you have a lot of these and you get limits of detection which are highly variable because of different surface areas. So it can just confuse the interpretation. Something else we found, I think this is a problem because this is a developing area, we don't always know what are the right questions to ask, but making sure that you collect enough supplementary data, the descriptive data, the characterization of the environment. We found ourselves going back a lot to get better descriptions of simple things like I just said, size of an object, or where on an object a surface measurement was taken. So I think putting a lot of effort into making sure that you ask this right the first time will help you, because as we all know, going back even a day or two later, it can be really hard to find out what was happening when you were taking the measurements. And anomalous results. We've scratched our heads many, many times over data, and this is, I guess, the fun of hygiene, the anomalous results. We've had more than one occurrence where we had people who ended up with more contaminated surfaces after they'd cleaned them before. And without going into any detail, I'm sure you've all got ideas, as we did, about why that was. But it's an example, for instance, of was the 100 centimeter squares you picked representative of the whole surface? We think in this example, when they were cleaning the surface, they were actually moving or transferring substance from a dirtier area into the area that they were cleaning, or sorry, sampling. And so something we considered that when we set up the next sampling strategy for that site. Okay, just to conclude, I think that you can see that surface wipes can be incorporated at really every part of exposure control programs. Clearly, they are intended to be part of the risk assessment. They have strong hazard communication potential, not only in showing that the substance is present on surfaces, but you can show that how much is present. You can show differences between surfaces. You can show differences in levels following different decontamination techniques and so on. So it's very powerful. Control hierarchy. Bruce mentioned that there are impacts on all levels of the control hierarchy. I'm kind of excited to think that we may be able to move away from a dependence on personal protective equipment when we learn more about the actual exposure levels and look at ways of more effective engineering controls and administrative controls. So here's an example of right from the USP 800 of a fairly generic sort of implementation recommendations. And when I read this, what I see is just that there's a lot of work, going to be a lot more work for hygienists. If any measurable contamination is found, so we already talked about that as an interpretation, how complex that interpretation actually is, and how meaningful it might be, and how we might be able to improve on that. The designated person must identify, document, and contain the cause of contamination. So how do we find the cause of contamination? Well, again, surface wipes are going to be very important there for tracing the flow of contamination through a work site, from, say, a contaminated vial through contaminated counters and so on. Such action may include the reevaluation of work practices, retraining personnel, performing through deactivation. I think the timing and the kind of sampling strategy that you choose will let you look at different aspects of the problem. So long-term or surveillance once every 6 months or once every year may only be good enough to really tell you whether your overall practices are working or effective, whereas shorter-term samples will actually get you, or shorter-term sampling strategies may be able to allow you to get at really these causes of contamination and so forth. Anyway, I think that these generic kinds of recommendations are going to need a lot of work by hygienists to turn these into effective practices. These kinds of banded responses are starting to appear. This is one from again, the pharmaceutical literature for recommended responses for different contamination levels of cyclophosphamide. So the third row down talks about different contamination levels, and then the kinds of responses that would be recommended. I think I've said this, we've all said this enough. There's a lot of work that the hygienist needs to do in understanding the basis of the surface limit, the critical health effects, and then thinking about your own work site, your processes, your tasks, and also the co-exposures, both through the airborne route and other dermal exposures. I think I'm just about out of time. We certainly learned a lot of interesting lessons, and I think I've pretty much covered all of these at some point during my talk, so I won't dwell on this. So in summary, you should know why you're sampling, be prepared, select appropriate surfaces, there's guidance for this, and also your sampling parameters appropriate for the question that you're asking. Consider the surface as a component of a complex exposure environment, and I refer to that Schneider paper to help you think about that. And remember that the TLV surface limit is intended to supplement the airborne TLV, that we presume that there may be co-exposures and that you need to respond appropriately, and that the TLV surface limit has a place as part of a comprehensive risk assessment and mitigation process. And with that, I will hand it back to Susan, who hopefully has joined us.
Hand it over. So thanks, Hugh. That worked out well. So some of the kind of general things that I'll be talking about, Hugh's provided some specific examples, and so I think in some cases I'll have a little bit of a kind of a reminder those factors that are really key to keep in mind. And otherwise, I think you helped me just make my talk a little more concise, so that's great. In this last segment, I'm going to introduce you to surface sampling and talk about some of the principles and factors to consider when setting up a program. So again, some of these Hugh already touched on, and I may have some specific details. Otherwise, I won't repeat those. And then after a short summary of my section, I have an overall summary of the webinar today. So the most common approach of surface testing is wipe sampling, and obviously wipe sampling is the focus of our talk today. But as you can see from the list shown here on the slide, there are numerous other methods that have been developed for surface testing. And the different approaches reflect the differences in factors motivating the sampling. So differences in the sampling motivation, differences in surface type, and differences in contaminants of interest. So why do we conduct wipe sampling? And again, Hugh talked about this. So just very generally, we conduct wipe sampling to identify the presence of a surface contaminant. So we could use qualitative methods, or we can use quantitative methods. And in the case of qualitative methods, we'll get a yes/no as to whether the contaminant is present above some threshold level. With the quantitative methods, we are informed of how much contaminant mass is on the surface, and as Hugh said, that's a snapshot in time. But if enough samples are collected, we can also get a sense of the spatial and temporal variability on that surface. With the quantitative sampling, right now that typically means we have to send the sample off to the lab. So that presents a lag time between when we collect the sample and when we get the results. But new direct reading instruments and sensor technologies are evolving. So it is bringing us closer to kind of near-time capabilities for the quantitative sampling. So why would we conduct sampling? And again, Hugh talked about some of the motivators. I just want to talk about some specific examples here. So in the case of environmental sampling, you may want to assess the potential for dermal exposure to contaminants such as pesticide residues following agricultural applications. And since many of these products are dermally absorbed, their presence on unprotected hands, clothing, or surfaces likely to be contacted by workers are of concern. It's also conducted to ensure that the local environment, so for example, homes and schools in the agricultural communities, aren't contaminated. So we're thinking here about both occupational and non-occupational exposure. Industrial hygiene surveillance sampling, again, Hugh just gave us a really great example. And so it's often conducted to, again, assess the potential for dermal exposure, informing us of the need for engineering controls, targeted training, hazard communication, and possibly PPE. And as, again, Hugh mentioned this as well, that it's also useful for the continuous improvement of housekeeping activities. So I think we're going to see this a lot with USP 800, where hospitals will get their kind of their baseline and then work towards constantly reducing the level of environmental contamination, thereby improving their housekeeping. Relatedly, wipe sampling may also be used following remediation to verify that the cleanup adequately removed the contamination of concern. More recent application of wipe sampling is security related. You've probably all seen the sampling being conducted in airports to check for the presence of explosives and biological agents. And then finally, compliance monitoring, as the name implies, is conducted to meet prescribed surveillance requirements. And again, Hugh mentioned USP as 800 as an example, and I will be talking a little bit more about that in a little while. So where is sampling conducted? Just very briefly, you can see in various locations, and this goes back to why are we sampling and what questions are we trying to answer. For the purposes of the rest of this talk, I'm going to focus on occupational indoor sampling, but as you can see, there are other areas that certainly can be conducted and is conducted outside as well. Recommended practices have been developed by a number of agencies, both in the US as well as around the world, by various organizations. So the table that's shown here is just to give you, show you a range of the contaminants for which there are methods, but also to remind you that there are also many more methods. In the reference section at the end of my presentation, I've included some of these sources, and they serve as good references to, if you're thinking about setting up a sampling program, it's a good place to start to see what's currently available in terms of guidance. So in here and in the next couple of slides, I just want to talk about some general considerations when setting up a sampling program, such as reviewing the literature to identify appropriate guidance and methods that fit your situation. So again, you've already heard this. What's the question? What's motivating your sampling? What is it that you want to measure? And so there you have a lot of options. And so it is really highly recommended to start by reviewing the literature and then select the method that most closely aligns with your goals or the questions you're seeking to answer. But before you do that, consult with the lab that you're going to use. There may be some specific sample collection requirements or some method limitations, and you always want to know about those, of course, before you go out into the field and start sampling. There's some really nice detailed guidance on critical analytical considerations provided in the OSHA document entitled Evaluation Guidelines for Surface Sampling Methods. You can find this online by a simple Google search, and I think I've listed it in my references as well. So among the list that you can see here is the consideration of the sampling media to make sure that it's sufficiently digested, as well as making sure that the matrix that's being used is compatible with the media and the wetting agent. And this is so that you have accurate extraction of the contaminant from the sample. Obviously, to have confidence in the results, the method has to have good linearity, and you'll want to know about the sample stability to have a sense of how quickly after the sample is collected that it needs to be analyzed before that sample starts to degrade. Methodological details such as identifying interferences, method recovery, and limit of detection must also be determined. And as Hugh mentioned, but it's worth repeating, the analytical sensitivity will vary by compound, analytical method, and even instrument. So again, if you want to make sure that you're using a method where all of these steps, all of the validation steps have been conducted so that you know that your method is robust and as well know what its limitations are. Several factors also need to be considered when planning and conducting the sampling, and one of the most fundamental factors, of course, is the surface type. So while there are several methods for sampling the skin, including removal and rinse methods, our understanding of how those contaminants on the skin, currently are limited. So, as our understanding evolves, these methods will become probably more common and more helpful. But right now, given the limitations of our understanding of this very complicated process, makes interpreting the results of the skin sampling challenging. For non-skin samples, an important factor is determining the surface porosity. So generally speaking, the more porous a surface, the poorer is our removal efficiency. So in you mentioned about the longitudinal study, there were surfaces that we chose not to sample just because we knew that, they were, for example, fabric surfaces. We just wouldn't be able to get the contaminant off the surface. Also consider the contaminant properties, as they can vary widely, and that those properties will impact the propensity of the contaminant to persist on the surface, which will also affect how readily they're removed by a particular wetting agent. So earlier I mentioned we have qualitative and quantitative methods. Qualitative wipes can provide a real-time indication of the surface contamination above some threshold. So for chemicals like lead, in which any amount of lead in a, say in a school or a community setting is a call to action, this approach can be quite helpful and very cost effective. For the qualitative methods, again, it's obviously very important to know the removal efficiency, and one way that this is done is with the use of positive controls. So this is an integral part of the method validation, but positive controls can also be used during routine sampling as a means of quality control. And then, of course, there are ethical considerations when wipe sampling. Even when we're not sampling skin. So we really want to consider the reason for sampling and the questions that we're seeking to answer, and basically be prepared to answer those questions. We want to be ready to answer how should the results be interpreted, as well as what can't we say from them. And again, not to go on and on about this, but dermal exposure is complicated, and so the surface sampling can tell us about the potential for exposure, but doesn't tell us anything about the cumulative dose. You mentioned transportation as well. I just wanted to say that when you're trying to get these kits in and out of large companies or academic settings, it can be challenging, and it's a good idea to do a test run with with a dummy package before you send your precious samples off, lest they be left on a loading dock for the weekend or left out in the cold to freeze. So there are some common components of wipe sampling that are common across methods, such as the fact that we have to use some type of sampling media and wetting agents. But as you can see from the table here, there are a number of types of media and different wetting agents that will vary by the contaminant. So again, it's illustrative of the broad range of the variability in the media and the wetting solvents and the wiping area that you use. So again, it just underscores the value in checking the literature and consulting with the lab before you select a specific method. There are some common conventions, and one of those conventions is around the actual physical action of collecting the sample. And the key here is to be systematic and completely cover the surface. So in the guidance here from the OSHA document, they show how to collect the wipe sample using this S pattern. And then as you can see from the image below, how to fold the filter paper as you're working your way across that surface. Another common method for wiping the surface is this XY pattern. And in fact, this is what we used in our study. There's a YouTube video that demonstrates this technique. And coincidentally, in the current version of that video, we do talk about using positive controls. It is a good idea, I think Hugh mentioned this as well, it is a good idea to practice the technique before conducting the sampling, just to ensure that a consistent pattern is followed and that the pressure applied is somewhat consistent to help reduce the sample-to-sample variability. So with that, let's now take a look at some specific applications. When assessing pesticide residues that could potentially contribute to dermal exposure, one way to do this is by using the OSHA method 62. And with this method, these samples are collected using surgical gauze pads and that are wetted with either water or isopropyl alcohol. And then the samples are sent to the lab and analyzed by GCMS. With the security wipes, which I mentioned earlier, these are sampled with the single-use wipes, and then either using a hand or a wand, and then they are analyzed using these field portable ion mobility spectrometers that provide near real-time detection. And these instruments are able to detect a range of nitrate-based explosives, as well as several types of narcotics, as you can see listed here. Wipe sampling in occupational settings, of course, has long been recognized as a valuable component of a comprehensive exposure control program for industrial hygienists. If there's a quantitative surface limit, then collecting the samples provides an objective way to assess the adequacy of the housekeeping measures. But even without the surface limits, wipe sampling can alert us to potential dermal exposure risks. As Tracy reminded us earlier, surface contamination can exist at levels that can cause a toxic response but be invisible to the naked eye. So wipe sampling can reveal exposure opportunities and gaps in housekeeping before workers are overexposed. Wipe sampling may be a required component of surveillance program, and Hugh talked about this. And so I just want to, I won't dwell on that, I just want to make a note that the OSHA technical manual that, again, is available online provides practical guidance on wipe sampling. And so it's just a very good reference to have. Provides very practical guidance. So focusing on just a couple of illustrative case studies. I just want to check my time. Okay, we're good. Lead is a contaminant for which there are multiple wipe sampling methods. Industrial activities associated with lead that are well known include battery parts and fishel tackle manufacturing, as well as recycling. The historical use of leaded gasoline and leaded paint and environmental contamination in homes and schools also serves as a non-occupational source of exposure, and wipe sampling methods have been developed for both of these. There are qualitative colorimetric methods available, again, that just indicate a yes, no, if the contamination is above a threshold level. SKC makes these, as well as there are other vendors as well. There are more sophisticated quantitative methods, such as NIOSH method 9100. And NIOSH method 9100 is really sensitive. It has a reported limit of detection equivalent to 0.001 micrograms per centimeter squared for a 100 square centimeter area. And while there are no established surface limits outside of some very specific applications, for example, the interim standard for lead in construction recommends the use of the Housing and Urban Development's acceptable decontamination level of 200 micrograms per square foot for floors in evaluating the cleanliness of change areas, storage facilities, and lunchroom and eating areas. But again, even without surface limits, conducting the wipe sampling following this method can be useful for comparing surface loading, which can help reveal tracking of lead from a dirty area to a clean area. And it can also be helpful in identifying non-compliance with administrative controls. So still lots of value there in sampling. When following this method, coincidentally, filter paper is not recommended, as it's been found to be a little bit too flimsy and falls apart. There are commercial wipes, such as ghost wipes, that are often used with deionized water as the wetting agent. Of course, you'd want to wear appropriate gloves when conducting sampling, whether it's for lead or any other compound. But in this case, it's so that you don't contaminate the sample. All right. So documentation, and again, I know Hugh mentioned this. I just want to underscore the importance of capturing details around the conditions before you sampled and when you sampled, because as Hugh indicated, being able to make sense of those results, put them into some useful context, is dependent upon that documentation. Okay, another case study, and again, Hugh talked about this somewhat, so I'll be brief. But as you can see from the figure on the right, and this comes from the NTP monograph that was published last year, even though there have been multiple issues of handling guidance, there has been the development of some engineering controls and various technological developments to help reduce the exposures in the workplace. Environmental contamination of these anti-neoplastic drugs has remained stubbornly consistent. So you can kind of understand the motivation behind this USP Chapter 800. In the earlier versions, and even in the current version, there's not a lot of guidance on kind of how, when, where to sample, how many samples to collect. And so because of the need for these better surveillance methods, but generally lack of data to support evidence-based sampling strategies, our team undertook a longitudinal surveillance study of 11 anti-neoplastic drugs over a 12-month period. So cyclophosphamide was one of those. And again, in the interest of time, I won't go into a lot of detail. I just wanted to mention that we did use a validated method. So this is a method that was developed by the researchers at UBC. We used filter paper as our sample wipe that was wetted with this methanol water mixture. On the bottom right, you can see the sampling kit that was provided by the team at UBC, and it contained everything we needed to sample. You can see kind of in the center of the screen here, this cooler, so samples were shipped and shipped back, and so in a way that they were kept cool. We had acetate templates provided to be sure that that we were wiping 100 square centimeters, or in some cases the surface area was slightly different, as you can see here from this IV pump, but those were pre-measured before we conducted the sample so that we knew the exact surface area that was covered. Okay, so just to summarize, objective methods for determining the residual surface contamination are being developed. They indicate the potential for dermal exposure. The methods vary widely, as does the variability in the removal and recovery efficiency. So be sure to use validated methods where these factors are quantitated. The contextual details around the environment where the samples were collected are really critical. And if evaluating housekeeping effectiveness, it's really helpful to have a surface wipe limit to compare against. And as I mentioned, these are the references. And I don't know if we want to take questions from this last session before we do the final wrap up.
Yes, let's go ahead and take questions. So for those that I've assigned to each, if you wouldn't mind reading the question and providing an answer. Thank you.
Yeah, Dino, I'll go first. This is Bruce. I had a number of questions come in right at the end there, actually, when I was trying to answer questions. So now that I see them, I can answer them. The first question was, how do you develop a derived limit when you have multiple contaminants? And I think there was a similar question regarding metal working fluid. And I think the answer there is, unless we had data for the particular mixture, if it was consistent like metal working fluids, we might be able to do it. Otherwise, it would have to be based on individual components. And if we had an idea of which ones were actually the sensitizing agents, we might be able to provide guidance on those specific compounds. Many of those probably don't have TLVs, however. There was a question about contaminated clothing, and if we could comment on the possibility for continuous dermal exposure. And I think there, it's kind of the distinction that we have to make between setting surface limits and evaluating and doing exposure monitoring, because we have to make certain conservative assumptions or kind of draw a line about how we're setting the limit, and then that has to be interpreted by the industrial hygienist within the particular exposure scenario. So the idea of having working with contaminated clothing is probably an issue of it in itself, but how the hygienist can evaluate that in terms of what the exposure might be to compare it back to the surface limit, which is based on certain assumptions. There was a question about respiratory doses and dermal doses, and it kind of raised the question of maybe kind of looking at like an additivity formula. So this is something that the committee will have to think about in terms of how we're setting surface limits on top of an inhalation dose, and how that might be taken into consideration for both, the airborne number and the surface limit. Monoclonal antibodies. I'm not aware of any evidence of monoclonals being sensitizers, but the fact that many of them are foreign proteins, a lot of them are humanized, and so they're obviously more acceptable to the human body, but it's conceivable that because they're proteins and that they could represent those a sensitization hazard. I'm not sure what the threshold would be in terms of doses or what the doses might be in a hospital setting, et cetera. So they're quite low. So I'm not sure that's a real important risk, but it's something to take into consideration. I know certain safety data sheets call them sensitizers, so we'll have to pay attention to that. There were a couple questions about the presentation of the limit in terms of micrograms per square centimeter versus 100, and does that mean we have to factor in another factor of 100? And I think it comes out in the arithmetic, and again it goes back to this is the limit, the safe level for that particular surface area, assuming contact and complete absorption, or the 10% assumption for the palm of one hand. So again, that's one of those things where you have to figure out how to draw the line between what's being provided in terms of a limit and how it's being assessed within an exposure assessment. There was this is the question I was trying to read. I only saw part of it, which is related to the size of the particle. And I think it's also a question related to the inhalation dose, depending on particle size, particle size selected TLVs. And maybe that's a subset of the total inhalation, but there's a TLV, there's a dose. It's very clear in the documentation where that dose, how it was determined in terms of the part of the lung that was being affected or the health effect. So those are the sorts of things that we'll have to take into consideration as we're setting the surface limits. I wouldn't go and automatically convert all the TLVs to surface limits. That's something that maybe we can provide general guidance later on in the paper or something, but for the time being, we're going to have to kind of go through them one at a time. One of the questions was, are we going to have separate documentations for surface limits? And yes, Dino?
If I can cut in for just a second. We are getting close to our time, folks, and due to our technical difficulties, if you wouldn't mind affording us a few more minutes, we will stay on to answer more questions. However, if you have to get off now, it's understandable. I will be putting together the questions with answers to provide to all attendees. So we will continue to stay on to do this, and hopefully you will be able to as well. Thank you.
Question about the dermal bioavailability question. Is it a standard 10%? Is it a constant? I think I tried to answer that earlier in terms of, well, we have that default assumption, but if we have compound-specific information, we'll try to use it. There's a question about additive exposures, and I think the same additivity concept would apply here, dealing with different compounds. One question was multiple metals, and there it might make sense, it might not. We'd like to think about how a particular metal causes sensitization. If there's enough overlap, then maybe, yeah, we ought to be thinking about additivity. I think Tracy answered the question about visual limits and thresholds. There was another question about, should we have another factor about like a contact factor? And I think, again, that crosses the line from setting the limit to applying it. So I think that's something that's important and should be taken in, maybe on the exposure side. Another question was, where do the LLNA values come from? And that came from this test, the murine local lymph node assay, which is a standard test where mice are exposed to the compound a couple times, and then the lymph nodes are removed after given some radioactivity, and they measure the counts in the scintillation counter. So it's just a standard animal test, and that's where the EC3 comes from. I didn't want to spend a lot of time on the details of the protocol. Are we, sounds like we're going to be setting limits for systemic effects. Shouldn't it apply to all TLVs since there's a lot of systemic effects? And again, no, it would be only those where we thought that there was a significant potential for dermal absorption and evidence that, like the skin notation, it's not just it gets in, it has to do something. So, if it has a skin notation, we would be looking at the type of effect that were produced perhaps with dermal exposure. So it would be very selective, it wouldn't be all TLVs, it would be the ones that make sense from that perspective. And then two other ones here. So someone was acknowledging the difficulty in validating sampling techniques. I guess that's true. This is all new for everyone, or it's relatively new. We talked about combined exposures, metalworking fluids. Can you comment on the applicability of a surface limit to beryllium? I think the Department of Energy has a surface limit for beryllium, so I'm not sure how. I guess that would be a place to go to determine how that would be applied. And then there's one more question about the possibility for incidental ingestion, and that is something that is important, although it's considered kind of minor. Although in the pharmaceutical industry with potent compounds, it's more than that. There is some guidance, and I just wanted to mention that, Dino, before we stop, and that is the Nuclear Regulatory Commission has a document called the Technical Basis for Calculating Radiation Doses and Building Occupancy Scenarios Using Probabilistic, goes on. Basically, they have some terms here, assumptions in terms of ingestion rates, like 1/100th of a square meter per hour. And so those are the sorts of things that the hygienist, I think, should be paying attention to, maybe even on the limit setting side in terms of how much of a contribution that could make. So I'll stop there.
Hugh, you had some questions to answer, and Susan, can you guys please do that?
Sure, yeah. A few of the questions I have, Bruce has touched on either directly or indirectly, and I'll skip those, but I guess they'll be in the written set of answers. Just a few things here that I thought were interesting. Somebody asked whether these approaches apply to non-dusty chemicals, and absolutely. And they also asked about the liquids that may be absorbed into surface coatings. I think that brings about a point that Susan raised about persistence on surfaces varies greatly with the kind of surface, and so very difference between glass and stainless steel and wood and so on. And then the question is, how accurately is the surface wipe method mimicking the transfer to human skin, something to be taken account again into the interpretation of the data. Somebody else asked about compositing samples. I think that's a great idea. So if you've got your first level of assessment could actually be combining multiple samples, and if they're all negative, then you know, you stop, and if it's a positive, then you go back and do a second round of sampling to identify the contaminated surface. And then just briefly, someone asked about my cleaning versus decontamination. I run afoul of this terminology all the time. Yes, they are completely different things, as are deactivating and disinfection. And it brings up an interesting point, something that we're hoping to study here, about what happens when you clean or deactivate or disinfect, as often happens in hospital settings. What's actually happening to the contaminant? So if you're sampling for contaminant X and then you clean with some agent or deactivate with some agent, and you measure for agent X again, it may appear to be gone, but of course what could have happened is you could have chemically altered that substance. And so we're intending to do some research on appropriate or typical cleaning and deactivation processes, and look at reaction products and their persistence on surfaces. I think that's probably all of the major questions I had, and I'll stop there.
Okay, and I had a few questions. One was asking about if we knew how the EPA came up with their new lead in dust hazard surface level of 10 micrograms per square foot. And I don't know offhand how that was derived. Another question: are there any generally accepted defaults for deriving surface limits? For example, the number of touches per 100 square centimeters per day. This is in reference to regulatory bodies, and I'm not aware of any specific defaults, but perhaps Bruce or Tracy or Hugh, I don't know if you know of any.
I'm not aware of any guidance.
Okay, thank you.
Me neither.
Okay, thanks, Tracy. All right, what type of media do you use for hexavalent chromium? We use a quartz filter and it falls apart while wiping the surfaces. So there are there's some commercial wipes, and the name is escaping me at the moment, that are recommended for hexchrome. So I can send out a response to that question after the session, unless anybody else.
Susan, could you use ghost wipes?
You could use ghost wipes. Thank you. Okay, next question. Is sampling inside an engineering control recommended? For example, sampling inside a fume hood, which could potentially contain a chemotherapy drug. Well, that's going to depend on what question you're trying to answer. In the study that we did sample inside the biological safety cabinet. Our motivation was to try to understand the magnitude and variability of surface contamination for the purposes of developing a sampling strategy, or for recommendations for a sampling strategy. So, you know, the short answer is it depends. Again, you would just want to know why, you want to understand what question you're seeking to answer before you collect the data. What are the best wipe sampling references or guidelines for heavy metals? So I mentioned the OSHA technical manual. That's a great place to start. There's a really good literature review. It's listed in the references, and from that literature review, there are several guidance documents that are referenced. So I would start with that literature review, and that will give you a really good sense of the guidelines that are out there. Have you ever used quality control techniques of repeatedly resampling the same 100 square centimeter area with a series of wipes to derive the percent recovery? So I have not. That would be a good question for our lab person who is the individual who developed and who did the studies of recovery. We did do some resampling, not of the same 100 square centimeter area, but the same surface, to get a sense of spatial variability. So that was answering a different question.
If I can step in, Susan, yeah, that is published, and we can add the reference, at least the laboratory recovery studies are published, and we can add the reference to Dino's reference list.
Oh, thanks. Yes, of course, that would be really helpful. Okay. And there's a comment here about collecting white samples of lead, but lead is not a sensitizer. And a comment to say that Brookhaven said not to use ghost wipes for hex chrome. So that Brookhaven guide, that document actually, again, provides a table with some good guidance on exactly what to use for the specific metals. And I think that's all of the questions for me. So with the last couple of minutes, I just want to do kind of a wrap up to bring it all together. Let's see. Okay, let's go back up here. Here we go. Nope. So again, just a reminder that the TLV safe surface limits are designed to be safe levels of indirect contact of exposure to chemicals that are deposited on workplace or facility surfaces. So they're designed to serve as objective benchmarks. They are derived from the LLNA EC3 / the HRIPT NOEL ratio. And you can see here that there's a range of adjustment factors that may be used when setting those limits. The most common method for assessing surface contamination is wipe sampling. There are several guidance documents. You saw those in the tables. And again, they're listed in the references at the back. So I would definitely recommend starting with those documents and also looking at the literature to see if there are more recent publications out there. Methods for assessing surface contaminations have been defined, as you saw, by multiple agencies, and to answer different questions. So be sure you understand what question it is you're seeking to answer, and then check the literature to see what's out there to help you. The methods vary widely, as you saw, as does the variability in the removal and recovery efficiency. So it is highly recommended to use validated methods when sampling. And then finally, as Hugh mentioned, well, I think everyone mentioned that the TLV surface limits are intended to supplement the airborne TLVs. So this is another reminder to read the TLV documentation, and that when used as part of a comprehensive risk assessment / mitigation process, the TLV surface limits are incredibly valuable benchmarks to enhance and strengthen our programs. And then finally, the hygienic guidance values are not health-based, but they provide important benchmarks for continuous improvement of occupational hygiene practices. And with that, if there are any final questions or final comments, Dino?
Thank you for attending this conference, this webinar. This will conclude the webinar at this time. Thank you.
Thank you.
Thanks.